Good morning. It's June 11th, and this is your daily brief in science. Here's everything you need to know. A vast whale necropolis has been uncovered in the southeastern Indian Ocean, stretching about 1,200 kilometers along the Diamantina fracture zone, with nearly 500 whale fossils found between depths of 4,200 to 7,000 meters. Natural causes combined with the site's distinctive V-shaped seabed geometry helped these whales accumulate and become preserved, creating a long-lasting deep-sea archive. The graveyard hosts diverse life, including jellyfish, tube worms, brittle stars, sea cucumbers, squat lobsters, and saltwater clams, suggesting many potentially undocumented species. The discovery is presented within a broader scientific context with access to a Nature publication and related references, and ongoing Nature News and Views coverage. The Nature paper detailing the findings has been published, and independent experts regard the discovery as a notable contribution to paleontology. An international team from China, Italy, and New Zealand conducted the expedition, highlighting extreme, lightless, high-pressure deep-sea environments that host surprising biodiversity. Remote deep-sea environments like these whale necropolises reveal vibrant communities and demonstrate the resilience of life under extreme conditions. The article outlines a quick overview, research highlights, and a discussion of how these findings fit into larger scientific narratives, with pointers to related works. Key researchers include Xiaotong Peng, Peng Zhou, and Shikun Song, who describe the finding as revealing deep-sea life and history rather than a barren abyss. The reporting is led by Stephen J. Godfrey, affiliated with the Maryland State Paleontology Collections and Calvert Marine Museum, signaling a solid paleontological reporting perspective. A new chapter in neutrino science unfolds as JUNO in China releases its first major results from 2 months of data. The findings, published in Nature, focus on precise measurements of how neutrino flavors change as they travel. JUNO detects electron antineutrinos from 8 nearby nuclear reactors about 53 kilometers away, using 43,183 photomultiplier tubes to capture light in a 20,000-ton liquid scintillator volume. The goal is to test subtle neutrino behavior and mass differences, contributing to our understanding of fundamental particle properties tied to the Big Bang. Spokesperson Wang Yifang acknowledged early skepticism about reaching the planned sensitivity, but underscored the success and high confidence in the results. The collaboration spans multiple researchers and institutions, with ongoing work to compare results across global detectors. The initial data cover 2 months of collection, and more data are being gathered to refine measurements and address questions about neutrino masses. JUNO's design cost around $300 million and combines a large mass with novel phototube technology to maximize light collection and energy resolution. In a Nature article dated June 10, 2026, signatories report that after 6 months of construction and just under 2 months of data collection in late 2025, JUNO achieved improvements over CAMLAND by roughly a factor of 20 in scale. With 59 days of data, JUNO reduced uncertainty on 2 oscillation parameters by about 1/3 and already observes pronounced spectral ripples indicative of the mass ordering. Neutrino mass can take 3 values. Current evidence suggests 2 masses are very close with a larger gap to the third, implying either 2 small masses and 1 larger, or the reverse. The results mark JUNO's first major milestone, with anticipation for more results as data collection continues. ACOG has issued its own 2026 immunization schedule for pregnant people, endorsing vaccines for COVID-19, RSV, influenza, and Tdap, signaling a break from CDC-aligned guidance. The organization notes additional vaccines such as pneumococcal, meningococcal, hepatitis A, and hepatitis B may be needed for those with specific risk factors and urges counseling with a healthcare provider. The guidance has drawn support from 13 other professional and medical societies and comes amid ongoing debates and legal challenges surrounding vaccine schedules and government recommendations. Providers say vaccine hesitancy and misinformation are widespread, making clear, evidence-based guidance from professional bodies crucial to countering myths. Social media-driven confusion is a concern, and clinicians welcome ACOG's clarified stance as a tool to help patients navigate conflicting recommendations. there is a perceived rise in vaccine hesitancy, with professional groups emphasizing accurate information to support patient decision-making. The article notes ongoing legal challenges and tensions around vaccine recommendations and the membership processes of CDC advisory groups. The move reflects friction between health professional groups and the CDC in the wake of Kennedy-era vaccine policy changes and related lawsuits challenging policy actions. ACOG officials say the recommendations aim to reduce confusion and are based on rigorous reviews of vaccine efficacy and safety data. A March 2026 federal court ruling blocked many Kennedy-initiated vaccine changes, leaving the CDC's ACYP in limbo, with HHS appealing. ACOG's independent guidance follows these tensions. ACOG leadership frames immunizations as essential to pre-pregnancy, prenatal, and postpartum care, placing OB/GYNs at the forefront of countering misinformation and guiding patient decisions. Press briefings featuring leaders from ACOG, AAP, and AAFP emphasize that OB/GYNs can address vaccine skepticism during routine prenatal visits. A new study argues that moving math into physical activity can change who engages with fractions and why. Researchers led by Jacob Wieneke at the University of Copenhagen tested a program called Basketball Mathematics, integrating fractions into weekly 60-minute basketball-based physical education for 11 to 13-year-olds over 8 weeks. Across 309 pupils, the intervention connected basketball activities like shooting and dribbling to fractions and percentages, and the results showed a 15% average improvement in fraction test scores compared with a non-playing control group, with about a 5% gain in other math concepts. The approach aims to reach students who tune out traditional math methods by combining movement with learning goals rather than just adding activity. The study, published June 6, 2026 in Educational Psychology Review, builds on prior work related to fractions and math achievement and suggests the method is transferable to other contexts. Understanding fractions is predictive of later math success, underscoring the importance of early improvements. The program ran 8 weeks and demonstrated that small changes in pedagogy can yield meaningful gains without lengthening total class time. A freely available teaching compendium accompanies the study, offering suggestions to adapt the approach to other activities, such as volleyball, while keeping alignment between movement and learning objectives. The researchers conclude that combining movement with learning engages students who are not drawn to mathematics, boosting motivation, enjoyment, and math performance, and they call for broader adoption of active math in schools. This has been your Daily Brief in Science. To read more about these stories, follow the links in the episode bio. You can also subscribe to these updates via email at www.brief.news. For more daily podcasts about the topics you love, visit brief.news/podcasts. Tune in tomorrow. We'll be back with everything you need to know.